Hi, last class you watched a video on section 10.1 and you were asked to sort of open up this quiz, attempt some of the questions on your own, and now we're going to run through the answers to this 10.1 quiz. Again, my suggestion for this entire chapter is actually read through the textbook and look at the problems in there. Many of the things in chapter 10 are similar to chapter 8. However, there are some different features that were mentioned in the last video, such as how do we find that critical value when we're dealing with means, and really this question one, how do you look at the intervals sort of differently? So question one on this quiz says you construct three different 88% confidence intervals. And we see that we have A, B, and C listed here. A and B are T intervals, again, with different degrees of freedom. And so, again, when they tell you the degrees of freedom, they're also telling you, again, degrees of freedom were found by taking your number of your sample minus 1. So that means in this first one, our number in our sample is actually 7. And in the second one, the number in our sample is actually 3. And the third one, they tell us our sample size is 30. It says, assuming the standard deviation is the same for all three intervals, write the intervals in order from this narrowest to the widest. So the most narrow is actually going to be letter C. The Z interval is always going to be a little bit more narrow because that critical value is going to be the smallest. And again, that has to do with the area in the tails of each of the two type curves. There's a Z normal curve, and then there's a T or a T distribution. T's are always have fatter tails, and therefore that means that the T values or the T critical values are going to be a bit larger. And what that means is the larger the sample size, we mentioned before, the closer it is to normal. So the sample size of 7 is closer to 30, which means that A will be the next narrow, or goes narrow, then sort of middle, and that means B is going to be the widest. The smallest sample size will always have the largest critical value and therefore the widest interval. So that's sort of your order and the explanations for that. As we kind of continue to look at, again, critical values, the next one says find the critical values. Again, they refer to that as T-star that we use for confidence intervals for means in each of the following settings. We mentioned this last class as well, so you might want to pause and get out your formula sheet. You are looking up critical values. Again, remember you do need to know the confidence level. The confidence level, again, for this first one is 95. It tells you the sample size. Again, this observations tells you that 20 is your sample size, or n equals 20, but you need to know your degrees of freedom. And your degrees of freedom, again, is that sample size minus 1. So our degrees of freedom are 19. So we're going to go to our table and look for our critical values there. So I'm going to pull up my table. When you look at the table, again, you're scrolling and you're looking for table B. So I'm kind of moving quickly. Table B, again, notice it says T distributions. We know our degrees of freedom from our problem are 19. So again, kind of related to you have to look at your degrees of freedom. And then it's helpful on your table, you'll see the confidence intervals at the bottom. I'm just going to scroll down. Confidence interval is sort of this column, 95. Notice it tells you the tail area is 0.025. Kind of helpful if you have a two-paged one like this. So we're looking at a critical value right here, a T-star of 2.093. That's all they're asking you for here. The critical value is 2.093. Again, doing the same thing here. Again, your degrees of freedom are 51 minus 1. Obviously, that makes 50. You're going to look up that in the table. Now, when you go to the table this time, and you're looking for a degree of freedom of 50, notice that 50 does exist, but notice that there's no like 48 or 49. You're always going to round down. So if you don't see the number that you're looking for, because obviously it starts to jump by 10s and then jumps by 20s, and then jumps by like a 900, If you don't see the number that you're looking for, always round down. We do have a 50 here. Again, it said it was a 90% confidence interval, so we get that 1.676. So again, our critical value is 1.676. Those are some of the things that we just kind of talked about in terms of Z and T distributions. Let's look at the next question. Question 3 says, below are graphical representations of two different samples from two different populations. In each sample, discuss whether that normal or large sample condition is met. Again, because we're dealing with means, we're really thinking of sort of that central limit theorem idea. Or again, if you've read through your book, and we've talked about this briefly, when your sample size is small, you hope to have a normal distribution for the population, and then therefore the sampling distribution would also be normal. Otherwise, there's some other things, and this is what's coming up. Like this, for example, is a very small sample size. It is not greater than 30. So the central limit theorem does not apply. We don't know what the population shape is, so we can't say, oh, because the population is normal, that means this is normal. So the next step is you don't just ignore it. They made a graph of their distribution. And so this again is called a stem plot. There are 12 outcomes. And again, this would be like 20, 21, 22, 26, 26, 27, 30, 30. That's how you read a stem plot. Again, if you kind of look at it from sort of the side perspective, there's a peak here, and then there are less values as you get larger. So we would actually say that this small distribution is skewed to the right. Because our small distribution is skewed to the right, and it appears to have outliers, and we could actually check. We could check the 1.5 IQR rule for outliers and see it's really, really close. And again, the sample size, n, is less than 30. Because of all of these things, n's less than 30, it's skewed to the right, there appears to be outliers. We would say that this is not, it's not satisfied. Has it been satisfied? The answer would be no. And we would say something like, it's not, it's not advisable to use the T procedures for this sample, because we don't think that the population is normal, the sampling distribution is normal. So this would be like, yeah, again, not advisable. Advisable. In this distribution over here, the first thing we notice is our sample size, and again, that is greater than 30. It does look a bit skewed, but because the distribution is greater than, or I should say equal to 30, because of that central limit theorem, we could say like, yep, totally fine. It would be safe to use the T procedures. And again, we just mentioned that idea of T procedure because these are not Z's. It's safe sort of here. It's not safe over here. Not advisable because of the skewness, the low numbers, possible outlier. Is advisable to use T procedures because the sample size is large enough, meeting that central limit theorem. So very similar to what we saw previously. Okay, so let's now flip over to the back and sort of do one more question. Okay, so our last question is about, 217,000 high school students took the AP exam in 2017. The free response section of the exam consisted of 5 open-ended problems and an investigative task, still true today. Each of the free response questions is scored 0 to 4, still true. For one of the problems, a random sample of students. So again, that's important. Sample of students is 30. I start to write these down. Their mean, notice how they write it with an X bar. That's because it's a sample mean of a score of 1.276 and a sample standard deviation of 1.230. So that's kind of what they give us. And says, first, find and interpret standard error. And again, we mentioned standard error before. You can actually go to your formula sheet and see the equation. It's not something you have to memorize. And you're just going to plug in those values. So plug those all in, you divide, and you get approximately 0.225. It does say interpret. Again, we haven't been interpreting in a while, but again, this would say if we take many samples of this size, what do we expect? We expect a sample mean score. Because we're taking these are our sample means, we expect the sample mean score will typically vary by about 0.225 from the population mean score. So again, we're talking about this is our sample mean, this is how much it varied by. We expect that if we take sample sizes of size 30, we expect the mean of these samples of size 30 to vary from the population by about 0.225 in terms of the score. B, when it says construct and interpret, you have to remember your 4-step process. So we're going to do a state step. We're going to have that plan step. We're going to have the do step. And we're going to have the conclude. And they expect you to have all sort of 4 of those parts to get full credit. Again, the state step feels a little redundant, but you're really kind of copying what they want you to estimate. You're saying estimate mu. And again, copying right what they said, the true mean score on this question with 99% confidence. So the state step feels very redundant, but they're looking for you to know and state what is the purpose of your whole task. The plan step, again, is to name it, and we called this a 1 sample T interval for mu. Again, it's a T because we don't know sigma. We only were given, sort of in the previous place, sample stuff. And then you're going to check your conditions. So again, the same conditions. We have our random condition. Actually state why we know it's random. Go back up to the beginning part. Show your work for that 10% condition. 30 is less than 10% of the total 217,000. And then the large count. In this case, we know our sample size is 30, which is greater than or equal to 30. So again, nothing different from chapter 8, just making sure we're doing central limit theorem. The do step is to show all of your work. And in your do step, really important that you tell people what your critical value is and that you state those degrees of freedom. So that we know there's 30, we know degrees of freedom is 1 less than that. We look that up in table B to find that critical value. This is sort of the setup, our point estimate plus or minus our critical value times our standard error. And again, if you want to do your margin of error, it's plus or minus 0.619. So my whole interval is 0.648 to 1.886. So that's your whole do step. Your last step then is that conclusion, and you're writing out your statement. So there's our conclusion. Again, we say it the same way we did in chapter 8. We're 99% confident that the interval from 0.648 to 1.886 captures mu, the true mean score on this question. So this B is like what you would see as a test question. You would see those same 4 steps that you saw in chapter 8. 10.2, which is what you should read today and practice problems on, is really just doing it for if you have 2 different groups instead of 1 group. So take some time, look over those questions, look at the videos that are also posted as part of the homework for 10.2, and then we will continue to answer questions in class. Thank you.